Alright, what's up guys? It's Probability by Pitman, Chapter 2, Section 1, Problem number 2. Suppose that in 4 families, each child is equally likely to be a boy or a girl, independently of the others. Which would then be more common, 4-child families with 2 boys and 2 girls, or 4-child families with different numbers of boys and girls? What would be the relative frequencies? Um, okay, so just to answer the first part of which would be more common, I think the easiest way to do that would just be to um, find the total number of combinations possible. So we have to realize that the order does not matter. You could have boy, girl, or girl, boy, girl for 2 boys, 2 girls, and it really wouldn't make a difference. So because order doesn't matter, we will use order rather than, or sorry, we will use choose rather than order. Where as a reminder, order is equal to n times. So if like k is equal to 1 or 2, then it'll be n times n minus 1. So there'll be 2 terms. And n choose k is just n factorial over k factorial times n minus k factorial. And we'll be using this one today because order does not matter. But if order does matter, then you use order. Okay, cool. So what should be more common? 4-child families with 2 boys, 2 girls. So that would be 4, choose 2, because we have 4 total children, of which 2 can be girls. And once again, order does not matter. So 4 factorial times 2 factorial times 2 factorial, since 4 minus 2 to get that second 2. All right, cool. So 4 times 3 times 2 times 1, 2 times 1. So we can cancel those. So it'd be 4 times 3. And then remember, 2 factorial is just equal to 2. So that's just 2. So that's 12 over 2, which is equal to 6. Cool. So then, which would be common? 4-child families with 2 boys, 2 girls, or 4-child families with different numbers of boys and girls? Okay, so for this one, we would just do for all the remaining possibilities. So for, let's say k is number girls, then we'll say 4 choose 0 plus 4 choose 1 plus 4 choose 3 plus 4 choose 4. So basically everything except the even number of boys and girls. So that would be 1, because 4 choose 0 is equal to 1, plus 4 factorial, which is equal to 24, plus 4 choose 3. So that would be equal to 4, right? Because 4 factorial over 3 factorial, that's 4 at the top, times 1. Yeah, so 4 plus 1, because 4 choose 4 is equal to 1. So then that would be equal to 30. And as we can see, 30 is greater than 6. So therefore, it's much more common for there to be 4-child families with different numbers of boys and girls than for there to be 4-child family with 2 boys and 2 girls. What would be the relative frequencies? And this is where we can use our good friend, the binomial distribution. So I'll go ahead and create a table for us. What would be the relative frequencies? I'm assuming they want us to do it separately rather than just either or for both of these, so I'll do it for each number, where this is number girls, this is p x equals number of girls, and this is p of x equals k, and then and these values are k. Sorry, this is really badly labeled, but you know what, it's fine. So this one would be 4 choose 0, where there's 0 girls, and we know girls have a half chance of being chosen, so it'd be half to the 0 times half to the 4, where there are 4 boys chosen. Then we do the exact same thing, so 4, 0, half. So this would be half to the 1 times half to the third, but because they both have the same probability, you can literally just add them together. And we can do the same for all of them. And I'll write this one out again just to show what exactly we're doing. Alright, cool. And if you calculate this out, then you'll have your frequency table. However, if they mean to say the frequencies of even number of boys and girls versus not even number of boys and girls, or equal number of boys and girls, then it's pretty simple. We can just do 2, 2, everything else, where 2, 2 is 2 boys, 2 girls. And 2, 2 would just be 4, 2 to the half to the fourth. And then everything else would just be everything else summed up. So I'll just say A is equal to this plus this plus this plus this. So whatever probability you get there, and then that's our A value. Yeah. All right, cool. I hope that helped, and thanks for